Imagine that you are sipping a thick milkshake through a straw. Now, that straw is getting clogged. That is what happens inside of oil pipelines, except instead of milkshake, the pipelines are clogged with asphaltene deposits. Asphaltenes are a complex mixture of hydrocarbons that can form under certain conditions. They can cause operational issues in the oil and gas industry and end up costing billions of dollars in losses. To try and remedy the losses, gas companies use BTEX solvents to clean up the asphaltenes. The problem is that these chemicals are extremely harmful to humans and the environment. But what if there was something safer that we could use? That is where D-Limonene comes into play. D-Limonene is a natural chemical found in the peels of oranges, lemons, and other citrus fruits. You can think of it as nature's oil. What makes D-Limonene so unique is that it is biodegradable, non-toxic, and renewable. By using an eco-friendly solvent, we make the world a safer place to live in. But how do we make D-Limonene more effective and cost-efficient? Well, I am testing it as part of a microemulsion, meaning I am using only a small amount of oil combined with water and soap-like particles called surfactants. Surfactants are compounds that reduce surface tension between two substances, such as oil and water. A surfactant is composed of a hydrophilic head, meaning it attracts and dissolves water, and a hydrophobic tail, meaning that it dissolves oils. This dual structure allows the surfactants to surround and break up oily substances. Essentially, they help to mix the oil and water together and keep the solution stable over time. My job was to test different microemulsion formulations and see how well they wet the surface of asphaltene. I did this by measuring something called the contact angle. This is the angle formed when a liquid drop meets a solid surface. The smaller the angle, the better it spreads and cleans. Each tube had a different salt concentration, which is also called the salinity. By comparing D-Limonene to xylene, a known BTEX solvent, we were able to show that D-Limonene performs better even in microemulsion form. Many factors can affect performance of a microemulsion, including surfactant type, temperature, and salinity. By making these tweaks, we can make our formula even more effective over time. As a high school science teacher, I joined this project to help students see that science is for everyone, especially for solving real-world problems. Even though I don't have much experience with microemulsions, that didn't stop me from learning different scientific processes and helping to further this type of research. And you can do this kind of work too. I didn't grow up with all the answers, I just stayed curious and kept asking questions. Science isn't just something in a textbook, it's something you can use to change the world. If I can do it, then so can you. From oil spills to cleanups, your ideas matter. You can do anything if you set your mind to it.